Good morning, friends. Welcome to Water Resources Engineering class. In today's lecture, we focus on the next part of hydrology, which we call it as the abstractions from precipitation. The abstraction means the losses. So what are that? The entire precipitation which we get, the entire rainfall which we get is not available to us as surface runoff. The entire thing is not flowing on the surface of the earth. Only part of it is flowing. What is the rest? What happens to the rest? The rest is losses. So if I write the equation, the precipitation minus surface runoff is equal to the losses. What those losses consist of? Number 1, interception loss. Number 2, evaporation loss. Number 3, transpiration loss. Number 4, infiltration loss. Number 5, depression storage. Number 6, the watershed leakage. So there are 7 losses. In those 7 losses, now let us focus on the one of the important loss which we call it as evaporation. So the now focus is on the study of this particular loss called evaporation. What is evaporation? First, then after knowing what is evaporation, then on what is the process of that evaporation, and rate of evaporation or rate of vaporization depends on what factors. In turn, they are nothing but the factors governing the evaporation and how to measure the precipitation, the evaporation. So these are the topics that which we have. Slowly, let us take one after the other in the coming in this lecture itself. So the evaporation, what is the definition of the evaporation? Evaporation is a physical process. Evaporation is nothing but it's a physical process by which the water is transformed from the liquid state to the gaseous state. Water is transformed from the liquid state to the gaseous state. That is very, very important. Evaporation is the physical process by which the water is transforming from a liquid state to a gaseous state, which we call it as the vapor state, when at temperatures below the boiling point. At temperatures below the boiling point. From where it occurs from the surface of the liquid when as it gains energy to overcome the forces of attraction. When once the water molecules get the energy to overcome the forces of attraction, they break it and escape into the atmosphere as evaporation. Please remember that evaporation is a continuous process. We may not be able to see with our naked eye how the evaporation is taking place. Only when you go for boiling, naturally you may observe the vapors, water vapors coming out. Otherwise also from any liquid surface, evaporation is a continuous process that takes place. That is one of the very, very important points you should remember. In hydrology, evaporation is the major component of the hydrologic cycle. After precipitation, one of the major components is evaporation, returning water from the land and water bodies into the atmosphere. That is the thing. How you express it, the evaporation is expressed in terms of depth of water in mm, which is escaped from a unit area in a given time. In a given time, from a unit area, whatever water that is escaped from the surface of the water is what we call it as evaporation, and it is expressed as mm per hour or mm per day. What is the process of that evaporation? I'm telling that it is only after gaining some energy, automatically they break the forces of attraction, and the water vapor or water molecules come out into the atmosphere as water vapor. But let me explain that as a process actually. What is the first thing? First thing is absorption of heat. The moment the water surface absorbs the heat from the solar radiation, actually, main sun is the energy actually. From the sun, actually, the molecules get the energy, right? Get the energy and absorb that heat energy. Absorb the heat energy, basically. First thing is absorption of heat energy from the sun is the first point in the process of the evaporation. When once the absorption of heat energy takes place, what happens actually? What happens is it increases the molecular kinetic energy of the water molecules. The absorbed heat increases the kinetic energy of the water molecules. When once that is the kinetic energy of the water molecule is increased, they start agitating, they start moving faster. That's what is happening. When once that is there, because of the energy of the molecules is more, because of the more energy, naturally what will happen? Some of the molecules have more energy compared to the intermolecular forces. So naturally they break that intermolecular forces. That is first thing, they break free from the liquid surface and become water vapor actually. So first thing is absorption of heat. Absorption of heat from where? From the sun. Because of that, what is happening? The kinetic energy of the water molecules is increasing. When once the kinetic energy of the water molecules are increasing, they agitate. They start moving actually. So if they get sufficient energy, what will happen? The energy is more than the intermolecular force which is binding them. So naturally, they break the free surface, they break the water surface, and then become the water vapor. And then actually what will happen next? The diffusion into the atmosphere. When once the escape from the surface of the body, surface of the water body, then they diffuse into the atmosphere. The water vapor diffuse into the atmosphere, mixing with the atmospheric gases, atmospheric air. But that is there only. Then this is a continuous process. So as long as heat is available, as long as the sun's radiation is available, unnaturally the atmosphere, the air can attract, can accept more and more molecules. Automatically this evaporation is a continuous process. Two things should be there. One is the solar radiation, the heat energy. Second one is the surrounding air should accept this water vapor. If these two things are there, evaporation continues. So evaporation is nothing but absorption of heat actually. Once absorption of heat, then at the water surface, the kinetic energy of the water molecules increases. So when the water molecules energy increases, they break the things and escape of molecules and then diffuse into the atmosphere. Then the rate of the evaporation depends on so many various factors. There may be some of the physical factors, some may be meteorological factors. So it is a combination of physical factors and meteorological factors on which the rate of evaporation depends on. In turn, these points are nothing but actually on what factors evaporation process depends on. The evaporation depends on. Both are same, but only we explain it differently. So the rate of evaporation depends on, as I already mentioned, number one is solar radiation. The primary source of the energy is primary source of energy for evaporation is solar radiation actually. The higher the solar radiation, the higher the temperature, more energy for the molecules, more the higher the evaporation rate. That is the first point. Then actually air and water temperature. Evaporation rate increases with the rise in water temperature. The only moment the temperature of water is rising, naturally evaporation becomes faster, and at the same time the air temperature is also high, then evaporation process will be very fast actually. So the warm water molecules require less additional energy to escape. Then air humidity, for example, humidity is nothing but the moisture content that is present in the atmosphere. If suppose already the atmosphere consists of more and more water vapor, then naturally it cannot accept more, what you call it as, more water molecules from the water surface. So in such a case, the rate of evaporation will be less. If suppose already humid, then evaporation slows down. That is because already the air above is completely saturated, in the sense that it is completely filled with water vapor. It cannot accept any more water vapor. That is the problem. Whereas if the air is dry, that means relatively less humid, then naturally evaporation is faster. Please note that the humidity is one of the very important factor. Humidity is one of the most important meteorological factor actually it governs. Solar radiation is number one and temperature actually number two. These are first. Then afterwards the meteorological factors such as humidity we have touched. If already it is a humid environment, mostly in the coastal regions where near to the oceans, actually if you see it, they are already humid. At such a place, the evaporation is not actually the faster, it slows down. Whereas wind speed, if you take it, suppose there is no wind speed at all, the wind speed is almost negligible, then what will happen? Whatever the water molecules that are escaped from the water surface, that complete moisture is above that water surface only. The entire moisture area above the water surface is filled with only the water vapors actually. So naturally after some time, naturally there is enough moisture there, so it cannot accept any water vapor into it. So that is why wind speed is one agent. If the wind speed is there, then naturally it takes away, it moves away that, so that again whatever the water vapor that is coming from the surface of water, it has space, it has a space to occupy. So that's why the air can air can accept these water molecules. So that's why higher the wind speed, higher the evaporation. Please note it. So we talk about humidity, we talk about wind speed, we talk about solar radiation and the temperature. And coming to the atmospheric pressure. The atmospheric pressure on the surface of the earth, we may not be able to find much difference. It is almost similar. For example, if you go to high altitudes, for example, very high altitudes, the more you are climbing onto the mountains and reaching to the higher altitudes, what will happen? The more you are going up and up, what is happening to the pressure actually? Pressure is decreasing. When the lower the atmospheric pressure at high altitudes, the evaporation, because the evaporation is more prominent, rate of vaporization is very fast. So that's why it enhances evaporation. That is the first thing. Suppose if you go to the valleys, if you go into the mines, where the pressure is naturally increasing, then naturally there where the atmospheric pressure is increasing, if you go into the mines, go depth, actually the evaporation process is very slow actually. So that is regarding the atmospheric pressure. Then quality of water. If you take fresh water, for fresh water actually, if you take it, the evaporation is faster. From the freshwater surface, the rate of vaporization is very fast. But of course, if you take any water which is consisting of some dissolved salts, such as for example saline water, such places actually, because of them, naturally the evaporation process gets slowed down. So that is why, if you take it fresh water from, if you take it, evaporates more basically, whereas saline water evaporates slowly than fresh water. So these are the things that you should remember. Then surface area of the water body. Suppose larger the surface of the water body, if any reservoir or any pond is larger surface area, the more the area it is exposed to air, higher the evaporation. That is the first point you should remember. then vegetation cover or land cover. For example, on that entire land, if suppose vegetation is there, from the vegetation is also there is evaporation, which we call it as transpiration. But if you take it, the water loss from the soil is reduced if we have the vegetal cover. Actually, the evaporation from the soil or water surfaces is becomes very less actually. Then the next one is nature of the surrounding surface. If the nature of the surrounding surface is more dark colored or rough surface, they may absorb more heat and enhance evaporation. Suppose the surrounding surfaces are shiny or light colored, then they reflect heat, reducing the evaporation. Then coming to the last point, depth of water body. If the depth of water body is very shallow, the depth of water body is very small, then evaporation is very high, because from the surface of the water, naturally more and more evaporation takes place. But if it is a deep water body in a well-like thing, if you take it, then naturally as you go deep and deep, naturally temperature changes will not be much. So when there is no change in temperature, automatically evaporation is very less. So these are the 10 points you should remember on which the rate of vaporization depends upon. Then all this entire the rate of vaporization or the evaporation process depends on the Dalton's law of evaporation, where the most important points include, number one is the wind speed is one actually, which we should remember, and the other two are ES and EA. It is nothing but the saturation vapor pressure and actual pressure on the surface of water body, above the water body. So based on that, the evaporation loss equation, first time Dalton has given it, and this is the Dalton's law. So friends, in summary, in today's lecture, just we started with what are the various abstractions from precipitation, or what are the various losses once precipitation takes place, and in that the main loss is evaporation, and that's what we started. What is evaporation, that we have understood, and after understanding what is evaporation and what factors this rate of evaporation depends upon, that also we have studied. And in next lecture we will look for again the same, in other words I will explain, that is factors affecting evaporation. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.